Okay, so we've run 6 regressions. We made a table out of them, and that's great. We have a regression table to go in the body of the paper and the appendix, but now we want to make a picture. So we've got to extract some of the information that was used to make that table and put it into a format that's going to be really easy to sort of feed into some ggplot commands to make pictures with. So the first thing I'm going to do is I'm going to make some smaller objects that just include information on the coefficients, the standard errors, the p-values, and the t-stats. So I'm going to lose, for each regression, I'm going to lose the information about the r-squared and lose the information about the number of observations and some of those kinds of things, right? So I'm just going to save some slightly smaller objects. And so what I'm going to do is I'm just going to save this coefficients bit. So just tell me about the regression coefficients and a little information about each coefficient. So I'm going to summarize this reg poly. So this is the full regression output. Here's this reg poly object. And I'm just going to summarize that, pulling just the coefficients, and stick that in the simplified thing, just this S poly, just the real simple version here. So I'm going to create 6 smaller objects that we'll work with to create these data frames. Now, if we were to look at like what is one of these objects look like, you know, so if I look at like S egal 3, S egal 3. So now we see it's not a ton of information anymore. It's just for the constant term and the 2 independent variables. It's just the coefficient estimate, standard error, t-value, t-stat, and p-value. Okay, great. But we actually want to turn this into a data set or into a data frame. Because if I look at like structure of S egal here, you'll see that the current structure, right, is that this is just a numerical vector. Right, and so it's not currently a data frame. So we've got a table, right? Or sorry, it's not a vector, but it's numeric, and we've got dimensions, right? But we're just essentially a table here. We're not a data frame. So we're going to turn this into a data frame, and we're going to name. We're going to create var. We're going to use the row names out of SPoly as the variable names, right? And the coefficients are going to be the first value in each row of this table, or the second. And then the standard errors will be the next. P-value comes after, is the 4th, right? So of the 4 pieces of information we have about, so each row has a name. That's the variable that we're talking about. The first column then is the coefficient, second standard error, and the 4th column is the p-value. So we're labeling these things, and then we're creating another variable here, another column in the data, in this little mini data frame that tells us the name of the model that these came from. And you'll notice that as I'm going to create 6 of these little data frames, and I'm going to have poly, poly 2, poly 3, right? Different. It'll tell you which regression did this information come from. Okay, so this is, you know, code that creates this new data frame. So if I look at like, well, we just had a table before. If I look at this polydf object, right, now we have a data frame. We've got 2 observations of 5 variables, right? We have the name of the independent variable. We have the coefficient value, the standard error, the p-value, and what model this came from, which is always in this particular little data frame, the poly, right? So I'm going to do this 6 times, right? Once for each regression. Okay, and so now I have 6 new objects, which are actually little data frames, and they have this sort of nicely organized information that I've extracted from regressions: the name of the variable that we're talking about, the coefficient, the standard error, t-stat, and p-value. All right. Now we've talked about in our earlier data management videos that we don't use row bind and column bind a lot. You know, usually when we're combining big data sets together, we're going to use these full join and you know, sort of syntax, but here we're actually going to use row bind, and I've written this row bind command 2 different ways. We can use this little do.call function if you like it, which is slightly more efficient way to write some code where you're feeding in a list. In this particular case, we actually don't really need the do.call. We can just feed the 6 objects directly into our bind. So we can just run the code this way, but I wanted to, you know, at least throw out the do.call approach to things. So if you're kind of interested in loops and functions and kind of how to how to get a little more programmy about your use of R, get a little more, approach R a little bit more like a programmer, as opposed to just, you know, an applied social scientist like me with no real coding chops. Then things like do.call are good functions to learn how to use. Okay, but all I've done here is I've row bound these data frames together. So I've just stacked them on top of each other, right? Because I've given them all, you'll notice they all have the same variable names, right? As we're building these in, we have variable, coef, standard error, p-value model, right? And so I'm just now stacking these 6 little data frames on top of each other. And if I view what I've just built here, right? So I have the variable. So what's the name of the variable? Is this the constant, or is it natural resource rents of GDP, or is it natural log of GDP per capita, right? So it's going to be one of those 3 things. I'm going to have the coefficient estimate, the standard error estimate, the p-value estimate, and I'll have what regression model it came from. It's very slick. This is all the information that I need to make a picture, right? Any of those 3 pictures that we looked at in the first few videos here, we can make if we have these bits of information. So that's where we're at. The last thing that I do here, I'm actually going to calculate the upper and lower bounds on the confidence intervals for each of these coefficient estimates. You'll notice that in some of these pictures, right, we had the coefficient estimate and then a line that gave the 95% confidence interval. So to make that line, we'll need the upper bound and the lower bound there. And so what I'm going to do is I'm just going to use the mutate function to create an LB for lower bound and UB for upper bound variable. And the way you calculate the confidence interval, and this is, you know, stats we're not going to go into here, but that you can definitely look up elsewhere. It's just going to be the lower bound is going to be the coefficient minus 1.96 times the standard error. And the upper bound will be the coefficient plus 1.96 times the standard error. And that 1.96, I realize it kind of sounds like a number out of the sky, and to some extent it is. But with the normal curve, which you may have worked with in a statistics class before, 95% of the data falls within 1.96 standard deviations of the mean. So that's where this 1.96 comes from. The full linking and sort of explanation of confidence intervals, I sort of, you have to set outside the scope of these particular trainings. So those are useful values to have for some of the pictures we want to make. So I've added them in, and now, you know, if we look, and so after that code, you know, then we would just want to save what we've put together. So we have this df object that we've created. I'm going to tell you to save it into the training output subfolder here, and this I'll just call regression 3 lecture output with my initials and the date, right? And so this sort of scenario, right, here we're saving as an RDS format. So you use the RData format when you might have multiple objects. If you only have one object, it can be slightly more efficient to save it as an RDS file. If you saved it as an RData file instead, that would be totally fine. These are just native R data formats that are pretty easy to save data out and load it back in with these formats. And so the next videos will pick up kind of loading in a data object like this that has the variable names, the coefficients, what model they came from, right, the standard errors and all that, and actually making the pictures. So this is the data prep. We're about to go make some pretty pictures.